Have you ever looked at a truly massive bridge, one that stretches for miles across open water, and just wondered, how? How is that even possible? Well, today we're diving into one of the most incredible feats of engineering out there, the suspension bridge. These things are absolute marvels that seem to just laugh in the face of gravity. So let's figure out their secrets.
Okay, so let's put on our engineering hats for a second. You're standing on the edge of a massive body of water, or a super deep canyon. Your job? Connect this side to the other. The distance is huge, so long it almost seems impossible. What do? How do you even begin to design something strong enough to make that leap?
And that really is the heart of it, isn't it? A formidable challenge. Because we're not just talking about spanning a distance. We're talking about doing it in a way that's smart, safe, and actually, buildable.
Here's the real puzzle. For these crazy long modern bridges, it's not enough for it to just stand up. That's a given. You need a design that's also economically viable. You need something truly innovative, a solution that's both incredibly strong and doesn't cost $1 trillion. And that brings us to the hero of our story today. The answer to that seemingly impossible problem is just so elegant.
So what is a suspension bridge at its core? It's actually a beautifully simple concept. The roadway, the part you drive on, isn't being held up from below by columns. Instead, the whole thing is hanging, suspended, from massive overhead cables. That one idea is the key that unlocks these incredible distances.
And this gets us back to that economic point. This design became the absolute go-to for really long spans, especially for carrying things like cars and trucks, what engineers call relatively light traffic. It just hits that perfect sweet spot between jaw-dropping strength and using materials efficiently. So it's pretty clear that if the entire road is hanging from cables, then those cables have got to be the most important part of the whole setup, right? They are doing all the heavy lifting, literally.
And this says it all. The main cables are the absolute backbone of the bridge. Every single car, every piece of asphalt, every light pole, the weight of it all ultimately ends up being held by these massive bundles of steel. Their strength isn't just important, it's everything.
So how on earth do you make a cable that strong? Well, there are basically two main ways. You've got your twisted wire method, which is kind of like making a giant version of a normal rope. Or you have the parallel wire method. This is where thousands, and I mean thousands, of individual steel wires are laid perfectly parallel to each other and then squeezed together. This parallel method is often the winner because it packs more steel into the same space, making the cable denser, stronger, and way stiffer, which is what you need to prevent sagging.
But of course, the cables aren't just floating up there by magic. They're just one part of a really clever support system that's designed to take all that weight and funnel it safely down into the ground.
Let's follow the journey of the load. First, the weight of the roadway is held up by all those vertical cables, the suspenders. The suspenders then hang off the massive main cables. Those main cables carry the load up and over the tops of the giant towers. And finally, all of that incredible pulling force is transferred from the cables into massive concrete anchorages buried on shore. It's an amazing transfer of force from the air right into the earth.
Now, right at the very top of those towers, the main cables don't just scrape against the concrete. No way. They rest inside these huge, grooved metal supports called saddles. Think of them as a perfect cradle for the cable. They're super important because they protect the cable from friction and allow it to move just a tiny bit when the temperature changes or the wind blows.
So where does all that unbelievable pulling force end up? Right here. Buried deep inside a block of concrete the size of a building is the anchor plate. The main cables are literally tied down to this plate, which locks the entire bridge firmly into the bedrock. This is the immovable object that holds everything together.
And here are those critical connectors we talked about, the suspenders. These are the vertical bands made of super high-strength steel. Each one grabs a section of the road and hangs it from that main cable. All of them working together is what keeps that roadway perfectly level and secure.
So, when you put all these different pieces together, you don't just get a pile of steel and concrete. You get something truly special, a system where every single part is working in perfect harmony.
It really is like a symphony of engineering. The main cables are in tension, they're being stretched. The huge towers are in compression, they're being squeezed. The anchorages hold it all down to the earth, the suspenders transfer the load up, and the deck gives us the road to drive on. Every single piece is playing its part perfectly.
So the next time you drive across one of these magnificent bridges, don't just see a road. See the forces at play.
See that incredible tension in the main cables, feel the immense compression in the towers, and just appreciate the elegant system that lets you soar over the water. Ask yourself, what part of that engineering symphony will you notice first?